One of the drawbacks to an auto level and many of the other optical measuring instruments is that they require a two-person operation. One person to read the gun and the other to hold the leveling rod straight up and down in a vertical position using a rod level. The person operating the auto level looks through the telescope and focuses the eyepiece so that the numbers on the rod are clear. If for some reason you've gone outside with your students and have forgotten the rod level, here's a surveyor's trick. The rod can be rocked gently forward and backward toward the surveyor. When the rod is in its perfect vertical position, the distance between the stadia lines is the smallest. Remember, those are the lines on the top and the bottom. Remember, those are the lines on the top and the bottom of the vertical crosshairs. We will use them in a moment when we find the distances using the scope. The surveyor takes 3 readings through the scope: the top and the bottom stadia measurements and the crosshair measurement. These numbers are recorded in a surveyor's field notebook. Generally, field notes contain measurements, sketches, descriptions, and other miscellaneous information. Modern equipment may have an automatic data collector as part of the surveying instrument, but it is a very rare individual indeed who does not take supplemental notes in the field. The collected stadia and crosshair information are placed on the left-hand side of the field notes, while on the right-hand side we record sketches, descriptions, compass direction, date, time, weather, and names of workers. Any buildings, fire hydrants, or other objects are placed on the sketch so that the surveyor will have a better understanding of the site when he or she is back in the office. Now, let's quickly review the basics again. The assistant holds the rod vertical over a test point. The gun is focused so that the numbers on the rod are clear, and data is recorded in the field notebook. I think we are really ready at this time to go outside and collect some data. Hi, welcome to the corporate office of Project Lead the Way. It is here we're going to take some measurements and we're going to take our data, take it back inside the building and do some calculations. Now, let's pretend for just a second that we're going to act. What we're going to do is start by setting our tripod up someplace on the site. Now, if we were on a construction site, most often the tripod is set up in a permanent location and all elevation shots are started from there. But we need to set it up over what we call our turning point and then do a backside calculation to the corner of the building that, remember, we established at 100 feet. Lisa, would you please set up the rod on the point of reference? Use the rod level to keep it straight, please. Notice I've brought my engineering notebook with me. We're going to record the data that I read through my scope from that point that's back there. I'm going to begin by turning the auto level so that the crosshair locations are approximately in line with what Lisa is, and adjust it using this. Once I'm there, I can look at the crosshair and I know that my back sight measurement is, yes, 8.21 feet. The upper stadia, 8.50 feet, and the lower stadia, almost done, Lisa, thank you, 7.92 feet. So from this point, we're going to establish the height of our instrument, what we call HI, and then turn, and we're going to go and do our foresight reading. What I've asked Lisa to do is to set up over what we've established our test point 1 out in front of the tree, which we will measure in a short time in order to know exactly where we are. From there, we can move anywhere on the site. But right now, I need to take a foresight measurement from where Lisa is standing at this moment. Now that we've got Lisa in position, we know that she's level, she's actually done it. I'm going to again turn the scope. Use the crosshairs on the top in order to approximate where I am. Look through the eyepiece, use the focusing knob. Perfect, I've got it. Hold still, Lisa. All right, the foresight measurement. One double check. Yes, it is. 10.45, I've got it. The upper stadia, 10.77, and the lower stadia, yes, 10.13 feet. Very good. Thank you, Lisa. We're all set with that point. If we wanted to, from this point, we can still take other measurements, mark them as different test points, and do the same thing. We're just to continue to do foresight measurements because we are not going to change our turning point. Now that we're set up, I'd like to quickly show you how to use an auto levels instrumentation compass reading on the bottom to approximate an angle. I've got Lisa lined up, I've got the scope lined up, so I'm going to set this to 0. There's a mark on the side. I'm going to turn my gun to a stake I have planted in the ground. Yes, I've got it, and if you'll notice, I've turned approximately 40 degrees. This is not precise, it's only to the nearest degree. Well, we're all set. Let's go inside and do some calculations. Whether you choose to have your students set up an Excel spreadsheet to automatically do the calculations, or you ask them to do them by hand, putting all the recorded data into a chart is an excellent idea for staying organized. Ask your students to create a report based on the work they did outside. What I am showing you is a sketch based on the work which was done outside and the data entered into a spreadsheet. The first calculation to be obtained is the height of the instrument. The height is equal to the back sight plus the elevation height of the point of reference or benchmark. The elevation of any subsequent test point is the height of the instrument minus the foresight reading. For the example, before we do any horizontal distance calculations using Stadia, it is important to emphasize that this method is not an accurate method for finding the distance between 2 points. Using Stadia to calculate distances yields a rough estimate of the distance being measured. To calculate the approximate distance, one would subtract the upper stadia minus the lower stadia and then multiply that difference by the stadia ratio which is specified for each machine. Generally, this ratio is 100, but please be sure to check with the information which came with your auto level to be sure. For the example we are doing, the approximate distance from the point of reference or benchmark to the turning point is the upper stadia, 8.50, minus the lower stadia, 7.92, times 100 to give an approximate distance of 58 feet. Similarly, the distance from the turning point to the test point we called point 1 is 10.77 minus 10.13 times 100 to yield an approximate distance of 64 feet. It is now time to go outside, enjoy the sun, smell the fresh air, and survey the situation.